Ethernet in the first mile refers to using one of the Ethernet family of computer network protocols between a telecommunications company and a customer's premises. From the customer's point of view it is their first mile, although from the access network's point of view it is known as the last mile. A working group of the Institute of Electrical and Electronics Engineers produced the standards known as IEEE 802.3 or 2004, which were later included in the overall standard IEEE 802.3-2008. Although it is often used for businesses, it can also be known as Ethernet to the home. One family of standards known as EPON uses a passive optical network. History, with wide, metro, and local area networks using various forms of Ethernet, the goal was to eliminate non-native transport such as Ethernet over asynchronous transfer mode from access networks. One early effort was the ether loop technology invented at Nortel Networks in 1996, and then spun off into the company Elastic Networks in 1998. Its principal inventor was Jack Terry. The hope was to combine the packet-based nature of Ethernet with the ability of digital subscriber line technology to work over existing telephone access wires. The name comes from local loop, which traditionally describes the wires from a telephone company office to a subscriber. The protocol was half-duplex with control from the provider's side of the loop. It adapted to line conditions with a peak of 10 Mbps advertised, but 4 to 6 Mbps more typical, at a distance of about 12,000 feet. Symbol rates were 1 megabaud or 1.67 megabaud, with 2, 4, or 6 bits per symbol. The ether loop product name was registered as a trademark in the US and Canada. The ether loop technology was eventually purchased by Paradigm Networks in 2002, which was in turn purchased by Tone Technologies in 2005. Another effort was the concept promoted by Michael Silverton of using Ethernet variants that used fiber optic communication to residential as well as business customers. This was an example of what has become known as fiber to the home. The Fibre Networks company provided this service from 1999 to 2001. Some early products around 2000 were marketed as 10 bases by and Finon Technologies, although they did not technically use baseband signaling, but rather passband as in very high bitrate digital subscriber line technology. A patent was filed in 1997 by Peleg Shimon, Porat Boas, Noam Alroy, Rubinstein of Inoman Svadhyako. Long-reach Ethernet was the product name used by Cisco Systems starting in 2001. It supported modes of 5 Mbps, 10 Mbps, and 15 Mbps depending on distance. In October 2000 Howard Frazier issued a call for interest on Ethernet in the last mile. At the November 2000 meeting, IEEE 802.3 created the Ethernet in the first mile study group, and on July 16, 2001 the 802.3 working group. In parallel, participating vendors formed the Ethernet in the First Mile Alliance in December 2001 to promote Ethernet subscriber access technology and support the IEEE standard efforts. At an early meeting, the ether loop technology was called 100 base CU and another technology called EOVDSL for Ethernet over VDSL. The working group's EFM standard was approved on June 24, 2004 and published on September 7, 2004 as IEEE 802.3 or 2004. In 2005 it was included into the base IEEE 802.3 standard. In 2005, the EFMA was absorbed by the Metro Ethernet Forum. In early 2006, work began on an even higher speed 10 gigabit-second Ethernet passive optical network standard, ratified in 2009 as IEEE 802.3 ARV. The work on the EPON was continued by the IEEE 802.3 Extended EPON Task Force, formed in March 2012. The major goals for this task force included adding support for PX30, PX40, PRX40, and PR40 power budget classes to both 1G EPON and 10G EPON. The 802.3 BK amendment was approved by the IEEE SB in August 2013 and published soon thereafter as the standard IEEE STD 802.3 BK 2013. In November 2011, IEEE 802.3 began work on EPON protocol over coax. Description: EFM defines how Ethernet can be transmitted over new media types using new Ethernet physical layer interfaces, voice-grade copper. These new EFM copper, or Ethernet over copper, interfaces allow optional multi-pair aggregation, long-wavelength single optical fiber, point-to-multipoint fiber. These new interfaces are known under the collective name of Ethernet over passive optical networks. EFM also addresses other issues required for mass deployment of Ethernet services, such as operations, administration, and management and compatibility with existing technologies. Copper wires equals 2 base TL, defined in clauses 61 and 63. Full duplex long-reach point-to-point link over voice-grade copper wiring. 2 base TLPHY can deliver a minimum of 2 Mbps and a maximum of 5.69 Mbps over distances of up to 2700 m, using ITU-TG 991.2 technology over a single copper pair. 10 PASSTS, defined in clauses 61 and 62. Full duplex short-reach point-to-point link over voice-grade copper wiring. 10 PASSTS-PHY can deliver a minimum of 10 Mbps over distances of up to 750 m, using ITU-G 993.1 technology over a single copper pair. Active fiber optics equals 100 base LX10 defined in clause 58, providing point-to-point 100 Mbps Ethernet links over a pair of single-mode fibers up to at least 10 km, 100 base BX10 defined in clause 58. Providing point-to-point 100 Mbps Ethernet links over an individual single-mode fiber up to at least 10 km, 1000 base LX10 defined in clause 59, providing point-to-point 1000 Mbps Ethernet links over a pair of single-mode fibers up to at least 10 km, 1000 base BX10 defined in clause 59, providing point-to-point 1000 Mbps Ethernet links over an individual single-mode fiber up to at least 10 km. Passive optical network equals, the use of a passive optical network is a common example of fiber to the home. 1000 base PX10 defined in clause 60, providing P2 Northern Mariana Islands, 1000 Mbps Ethernet links over PONs, at the distance of at least 10 km, at the split of at least 1/16. 1000 base PX20 defined in clause 60, providing P2 Northern Mariana Islands, 1000 Mbps Ethernet links over PONs, at the distance of at least 20 km, at the split of at least 1/16. 1000 base PX30 defined in clause 60, providing P2 Northern Mariana Islands, 1000 Mbps Ethernet links over PONs, at the distance of at least 20 km, at the split of at least 1/32. 1000 base PX40 defined in clause 60, providing P2 Northern Mariana Islands, 1000 Mbps Ethernet links over PONs, at the distance of at least 20 km, at the split of at least 1/64. Additionally, clause 57 defines link level OA and M, including discovery, link monitoring, remote fault indication, loopbacks, and variable access. 2 base TL 2 base TL is an IEEE 802.3-2008 physical layer specification for a full duplex long-reach point-to-point Ethernet link over voice-grade copper wiring. Rates and distances equals, unlike 10 base T, 100 base T and 1000 base T PHYs, providing a single rate of 10, 100, or 1000 Mbps respectively, 2 base TL link rate can vary, depending on the copper media characteristics, desired link parameters, and regional spectral limitations. 2 base TLPHYs deliver a minimum of 2 Mbps over distances of up to 2.7 km, using ITU-TG 991.2 technology over a single copper pair. These PHYs may also support an optional aggregation or bonding of multiple copper pairs, called PME aggregation function. For a single pair, the minimum possible link bit rate is 192 kbits and the maximum bit rate is 5.7 bits. On a 0.5 mm wire with 3 dB noise margin and no spectral limitations, the max bit rate can be achieved over distances of up to 1 km. At 6 km the max achievable bit rate is about 850 kbits. The throughput of a 2-base-TL link is lower than the link's bit rate by an average 5%, due to 64/65 octet encoding and PAF overhead. Both factors depend on packet size. 10 PASSTS 10 PASSTS is an IEEE 802.3-2008 physical layer specification for a full duplex short-reach point-to-point Ethernet link over voice-grade copper wiring. 10 PASSTS PHYs deliver a minimum of 10 bits over distances of up to 750 meters, using ITU-TG 993.1 technology over a single copper pair. These PHYs may also support an optional aggregation or bonding of multiple copper pairs, called PME aggregation function. Details equals, unlike other Ethernet physical layers that provide a single rate such as 10, 100, or 1000 Mbps, 10 PASSTS link rate can vary, similar to 2-base-TL, depending on the copper channel characteristics, such as length, wire diameter, wiring quality, the number of pairs if the link is aggregated and other factors. VDSL is a short-range technology designed to provide broadband over distances less than 1 km of voice-grade copper twisted pair line, but connection data rates deteriorate quickly as the line distance increases. This has led to VDSL being referred to as a fiber-to-the-curb technology, because it requires fiber backhaul to connect with a carrier network over greater distances. VDSL Ethernet in the first-mile services using may be a useful way to standardize functionality on metro Ethernet networks, or potentially to distribute Internet access services over voice-grade wiring in multi-dwelling unit buildings. However, VDSL2 has already proven to be a versatile and faster standard with greater reach than VDSL. See also, PME aggregation function GSHDSL. 10 BROAD36, Ethernet over cable modem, ITU-G 993.2 VDSL2, passive optical network. References. Further reading, Beck, Michael. Ethernet in the First Mile, the IEEE 802.3 AFM standard. McGraw-Hill Professional. ISBN 978-07-07-145506-0. Whale-Dab, Howard M. Frazier. Ethernet in the First Mile, Access for Everyone. IEEE Standards Information Network. ISBN 9780738148380. External links. Get IEEE 802.3 IEEE Standard for Information Technology, Telecommunications and Information Exchange between Systems, Local and Metropolitan Area Networks, Specific Requirements, Part 3, Carrier Sense Multiple Access with Collision Detection Access Method and Physical Layer Specifications, IEEE STD 802.3-2008, November 2008. IEEE 802.3R, Ethernet in the First Mile Task Force Archive, download IEEE 802.3, EFM is contained in Section 5, IEEE EP 802.3 Ethernet in the First Mile Task Force official website. IEEE 802 LANMAN Standards Committee. Retrieved August 4, 2011. Ethernet in the First Mile FAQ. Ethernet First Mile Commercial Website. Southern Communications 2010. Retrieved August 4, 2011. EFM Knowledge Base at the UNHIOL.